So in Canvas, in our outcomes section, we have an outcome for chemistry class called 5A, using evidence effectively when expressing an original idea as a claim. And I'm pretty sure that in English class and in world history class, you also have some outcomes that are related to expressing ideas. So this is going to be similar to that with sort of a sciencey flavor. Because when we talk about evidence in science, we're talking usually about data. So data can be measurements or observations that you're making using one of your senses, right? So what you see, what you hear, what you can feel, etc. Um, and when we talk about evidence in science, there's often many ways to interpret something that you see. And we often talk about how evidence should be objective, meaning that you shouldn't be able to interpret it in multiple different ways. So all that said, because this can be a little bit confusing, I wanted to walk you through some examples of submissions for assignment 1.3, where I asked you to take this claim, matter is made of particles that can be separated from each other, and start to think about how you could find evidence for that claim in your everyday life, and then how you would kind of justify the claim using that evidence, using a reasoning process. Just a couple notes about this particular outcome, 5A, is that this is really only talking about evidence. It is not talking about reasoning. So I'm intentionally separating out the use of evidence to support a claim versus the use of reasoning to support a claim. In past years, I think that it got a little bit confusing using evidence versus using reasoning. So this outcome specifically focuses on evidence and how to use it effectively. So all that said, I have some examples for postings that kind of fall into different levels on the rubric. So levels 1 through 4. We're not talking about honors right now. Have more information on that later. But this is just honors. This is levels 1 through 4. And a couple general notes. We talked about this, similarity to English and world history. This, you might know this from other classes, but generally, when you submit something, you might end up, what you submit might meet proficiency criteria for higher levels than what you have, the work has earned. And so it's important to know that in order to earn a certain level, you have to meet all of the criteria for that level. And so, in other words, if you meet some of the criteria for level 4, but you haven't yet met all the criteria for level 2, the highest level your work can earn is level 2, unfortunately. But that's just really to make sure that we go back and we focus on what are those fundamentals that are in the lower levels, because those are, if you're doing level 3 and 4 things, but there's some fundamentals from levels 1 and 2 that are not being done effectively, then what you're doing at level 3 and 4 is not going to carry much weight. So it's almost like if you're building a tree house, but instead of building a tree house in a big strong tree, you're building a tree house in what's an example? Like, a tree with like a really, really flimsy trunk that's going to fall over really easily. It doesn't matter how cool or developed the treehouse is. If the foundation's not there, then you're in trouble. That's an analogy. So last general note, when you're stating data as evidence, really make sure that you're only including data that you are sure can be measured or observed. Okay, some of you in this first assignment, you're mentioning certain things that were not observable. Like they weren't things that another scientist could go and do and repeat. And so that's sort of a hallmark of data. And repeatable data is that, another scientist could go do that and verify, I got the same thing. So you must be right. I should agree with you and your claim. Okay. So looking down at these, when we're in like level 1 and 1.5 area, generally with these, what was presented as evidence was not really evidence in the sense that it wasn't really data. Like I didn't know how I would take the information in whatever was presented in the post. I didn't know how to use it to go do something to reproduce exactly what the author meant. So in this example, what's presented here is valid reasoning and valid like scientific knowledge, but it's not data. Again, it's not a thing that I could go do and say, oh yeah, I just did that. In this example, this one's a little bit tricky. The model here would earn a relatively high modeling score, and the reasoning here does make sense, but the evidence that's presented is a bit too much of a summary of knowledge, and it's tricky. Like I want to assume, like, oh yes, like this is evidence, but it's a little bit, it's what I want to see, if it's really evidence, is a presentation like, oh, a scientist could show that a single rock could be broken down into smaller pebbles. There's one discrete event that I could go repeat, right? And then you could take those smaller pebbles and break them into smaller pebbles, grains of sand, even. Another discrete event, right? But when you sort of summarize observations too much and just state sort of a general theory, like a general observation, then you're just presenting knowledge that's already been accepted, and that's not the same as evidence. Okay, so like you could say erosion happens, which is basically what this is saying, right? Like we know that big chunks of rock separate into smaller particles and that becomes sand, right? This is sort of summarizing the process we call erosion. But that's not it. I would say you're using, like, this is a use of information as evidence in sort of a literary sense, but I wouldn't say it's evidence in a scientific sense. It's not really specific data that I could go and collect myself. So level 2, this one, a lot of the postings were generally level 2.5 or above. Some of the things that happen with level 2 is maybe some people just included one piece of evidence. Like this was a really strong piece of evidence, but there's only one piece of evidence. So it can only earn level 2 because of what the criteria for level 3 says. And what the criteria for the description, for the criteria for the assignment said. Level 2.5. So in this case, evidence was presented, but some of the evidence, it wasn't like fully clear how it supported the claim. So in this case, we have the same claim. Matter is made of particles that can be separated from each other, but the evidence said that, okay, an orange can be cut into pieces and still be an orange. I would say that checks out. Go to the third one. Plastic can be broken or cracked, but never disappear. Okay. It'd be good to know that it's still plastic, still has the same properties. But I'll go with that. With the second one, water can be transported from one bottle to another and still keep its original properties. So this doesn't actually specify that particles are being separated from each other, right? Like you could maybe imply that based on what we know about bottles and water and everything, but I don't know. I would just like that to be worded more clearly to specifically refer to this idea of separation. Example 2, this claim only states that particles and matter can be separated, but the second piece of evidence mentions this idea of infinity. And so this is something that I know a number of you did. I think maybe 1 or 2 people did it early on in Piazza, and then a bunch of you were like, oh yeah, I agree, infinity works. So you really have to be really careful when you're using infinity in a claim. And I think I wrote a general note about it up here. Yeah. The general idea is that technically nobody can have direct evidence of something happening an infinite number of times, because you would need an infinite amount of time to observe something being done an infinite number of times. And no one who has ever lived, right, not you or me, has been able to make observations of something for an infinite amount of time. So by like through logic, it's not possible to have evidence of something happening an infinite number of times. So if you're talking about infinity, it means that you're making an inference, meaning an educated guess, meaning that you've seen enough data that makes you believe that with other data that I haven't seen yet, a process like separation could happen an infinite number of times. Like I could make that guess. And so in this case, when we're talking about making evidence-based claims, if you are specifying that this is like a theoretical claim and you're not trying to definitely prove, absolute truth, definitely what is, there's a gray area here. It's a little bit unclear, but I will say, like, I think your work will earn a higher score if you're talking about something like infinity that requires an inference like that. You'll get a higher score if you say explicitly this is theoretical. And so that's why, scrolling down here, this posting would earn a 2.5 because they say a piece of paper that can be cut into an infinite number of smaller pieces, right? Like no one has had that actual evidence. It would be more accurate technically to say a piece of paper can be cut into smaller and smaller pieces, right? It becomes inaccurate when you specify the infinite number of times piece. Okay. But if you look down here a little further, like this posting right here does also mention infinity. But they're actually making a more specific claim than most other people. Like matter is made of different particles that can be separated from each other infinitely. Yet in the evidence, at least in this first one, they provide a really specific example of data that I could actually go repeat, right? I could take a piece of paper, cut it in half, cut one of those halves in half, cut one of those halves in half. And there's a model that really clearly shows me what I should be doing. And so I could actually go do that. And so then they specify, as long as you have a sharp enough knife or tool for dividing the pieces of paper into two pieces, one could theoretically cut said piece of paper in half infinitely. So again, there's a theoretical piece that's really clearly identified there. And so I'm giving this the benefit of the doubt and saying, okay, there is a piece of really objective data that, I could repeat. It's hard to argue with. But then there's also this more kind of theoretical piece. Okay, so that's why this one would earn a 3.5. The other one would earn a 2.5. Level 3, generally, the requirement to get to level 4 from level 3 means that you need to have we'll look back here for a sec. It generally means that you need to have at least one graphical display of a data set, or at least one explanatory model. So either one, you choose which one, but you need to have one of those to help you represent and express your claim in a visual way. Okay, so generally anything in this example that's 3.5 or 4, it does meet the criteria for level 3, and it also has a model that's somewhat suitable or very suitable. Okay, so if you're looking for like, what would a level 3 be? Just look at the examples for level 3.5 and ignore the models for now. Just look at what's written. Okay. When we're looking at levels 3.5 and level 4, I guess the key here, and you can look more specifically at this document, but the key is that these examples are not trying to overclaim things, right? You're not saying that matter can be divided infinitely. We're just saying matter is made of particles that can be separated from each other. And there's a bunch of examples, right? You can take a piece of paper, rip it into multiple pieces of paper. It's still paper. You can take a piece of glass and smash it into smaller pieces of glass, right? Infinity is not mentioned. We're not trying to overclaim this idea of separation. And it is clear how every piece of evidence directly supports the claim. And I think, again, that's due to the fact that the claim is not trying to be too all-encompassing. It's not trying to incorporate infinity. I think this is the same idea, the way that these are worded. And I think, so this one, level 3.5, this example would earn level 4. The only thing is just that none of the examples have apples in them. So technically, if you're making an explanatory model that is helping you express an idea, specifically a scientific claim, the model should really represent what you are referring to in your evidence. Just because that it can really help your viewer understand, like, oh, okay, well, here's the evidence that I am supposed to be sort of taking in to my mind. And then here's the model that explains how I'm supposed to be thinking of that evidence. But with this example, I think everything else meets the criteria for level 4 generally. But like if my evidence is about an orange and a loaf of bread and water, technically I have to make like an extra mental jump to go from evidence to model. And a really, really, really strong evidence-based claim with a model won't require a reader to do that. Okay, so again, if you're going back to what we talked about on Friday a little bit, or what I mentioned, like if you're trying to be persuasive to help someone else sort of come around to your way of seeing things, then you need to make sure that you're making it as cognitively easy as possible for them to do that. So you want to make sure that you minimize the number of like mental leaps they have to make, which is why it's important in this case to have your model represent the data that's already being referenced. Okay. I hope that was useful. I know that there's a lot of detail I went into. The idea of infinity might not be something that you needed to think about, but I hope that it maybe gave you some food for thought, because you might have thought about infinity before, and maybe you were toying around with the idea of using the word infinity there. But I wanted to go into it. This is going to be a rubric that we're going to use, I think, quite a bit as we move forward this year. We've sort of touched on the idea that there's a lot of misinformation in the world right now. And I think part of that is that there's different ways that someone could interpret evidence, right? Or there's different ways that someone could think of what evidence really means. So that's why I started out with this, by really making sure to define what I'm meaning evidence to be in science and chemistry, right? I want to make sure that we're using a consistent definition for that, so that when we move forward, we're all sort of on the same page. So if you're ever not sure, like, well, what do we mean is evidence? You'll go back to this note section, ask questions in class. The big idea is that whenever you collect some data, measurements or observations, it's just data. But once you use it to support a claim, then it also becomes evidence, right? So something can be data and evidence at the same time if you're using data to support a claim. Okay. Anyway, that was it. Hope that was helpful. See you next time.